Globally, 66% of the world's energy generation is wasted as waste heat. Technologies nowadays cannot be used widely across a diverse range of energy generating systems. Solid-state technologies with much lower cost, space adaptability and environmentally friendly are in fact needed. Our team has developed a system combining solid-state energy recovery technologies as part of our effort to meet the global agenda of sustainable development goals, specifically in addressing the critical issue of energy security. A thermoelectric generator operates based on Seebeck effect, where it directly converts temperature difference into electrical output. With efficiency between 5 to 15%, TEG can be applied in space missions for self-sustaining electrical power. We proposed an original design concept based on combined heat and power, where simultaneous electrical power and thermal energy are generated from a waste heat stream. The unique design concept integrates three solid-state and high-efficiency technologies, which are TEG, heat pipes and heat sinks. Thermoelectric generator module partially recovers thermal energy from any industrial waste heat stream. Heat sink is positioned within the waste heat stream flow path, and convection heat transfer allows a portion of the thermal energy to be transferred from the hot side heat sink to the cold side heat sink through a series of subsystems. Heat pipes enhance the heat transfer with minimum heat loss. As the recovered heat flows across the TEG cell, direct current electricity is generated, with the magnitude depending mainly on the temperature difference and the zeta potential of the semiconductor material. The remaining heat is dissipated to a lower temperature fluid stream, enabling a regenerative heating process to be obtained from the waste heat stream. The main outputs from the TEM are electrical power and regenerated thermal energy. This unique TEM design allows the industries to increase energy utilization and reduce its fuel consumptions. TEG waste heat recovery module design consists of four main components with quantity specifications as shown. Heat exchangers are positioned at both hot and cold stream to enhance the heat capturing and dissipating of fluid. Case study from bread baking industry produces exhaust waste heat at temperatures between 230 and 270 degrees Celsius. This exhaust is normally rejected to the atmosphere. If the exhaust is instead channeled to our TEM system, then an amount of heat will be absorbed by the TEM to produce outputs which are a lower exhaust air temperature, electrical power generation and heating of the fluid stream. The regenerated heat will be used to preheat airflow and channel it to proofing oven that normally operates on natural gas burners. We have applied parameter sweep design optimization approach to obtain the best design for the bread baking case study. From the model optimization, an increase of 41% of waste heat utilization is predicted with 4 TEG cells. The major parameters influencing the TEM performance include the thermal capacity of the cold fluid stream and the size of the copper block housings. For future development, we aim to enhance the heat recovery ratio and obtain feedback from industries in terms of unique requirements for practical application. By integrating one TEM module, the industry could save a total of 3,157 ringgit Malaysia in 1 year from the power generation and heat recovery, with return of investment period of 16 months. Increasing TEM installation increases the yearly profit due to higher energy saving, but the return of investment period maintains at 16 months because of the linear in total installation cost. The marketability of this design depends on these factors. 1. Government regulations for industries to apply technologies for higher energy efficiency and security. 2. The achievable outputs in waste heat recovery ratio that influences the total savings and payback period. 3. Awareness on environmental thermal pollution effects leading to the importance of energy recovery efforts. We would like to reiterate that our design efforts for the TEM is part of our contribution to make the global agenda of sustainable development goals, specifically in addressing the critical issue of energy security, and to follow the 97th Act under the 8th focus in the 12th Malaysia Plan.
Created using Powtoon.